I want to say welcome back, everybody. This is amazing. Look at all this activity in the classrooms. It is time for your Q&A and your wrap up. We are ready to roll. We have two amazing college mentors here, along with Milton, who's going to be commenting on you. But the mentors are going to introduce themselves first, and then we're going to get right to you also, teachers. I hope you have some groups that are ready to share your bridge designs and with us so we can see what you guys all created. Teachers, if you have not turned on your cameras, please do so and get to those keyboards. But I'm going to stop speaking and let our two amazing mentors introduce themselves, and then we'll get right back to everybody's bridges. So, Morgan, if you want to take it away.
All right. Hello, everyone. Lonnie, can you share the next slide, please?
Yeah.
Welcome to your Bridges Q&A session. My name is Morgan Douglas. I am currently, or I just wrapped up my junior year out at Virginia Tech. I am a civil engineering student, so this is right up my alley. I'm originally from Annapolis, Maryland. So I'm kind of focused in on three different kinds of engineering. So there's sustainable land development, construction management, and water resources. If Lonnie can go to the next slide, I'll explain a little bit about my journey through engineering. So I was actually in the STEM program out at my high school. So I actually got a chance to clone some DNA back in high school, which I find really interesting, but it wasn't necessarily my forte. I did not really enjoy it. I find it interesting. It was great. However, it is not something I want to do for the rest of my life. But then I got accepted to Virginia Tech. And at Virginia Tech, we all start out as or as general engineers, and then we get to choose our main focus. So I switched into civil engineering after my freshman year. And sophomore year, I joined a couple clubs. I went to the steel bridge design team. So I actually design a steel bridge each year. So last year's bridge is completely different from this year's bridge, and it actually gets to hold 2,500 pounds, which I find pretty interesting. And last summer, I worked with a general contractor, so I did a lot of work with construction management. And then junior year, I actually coordinated the publicity for American Society of Civil Engineers' symposium for Virginia and West Virginia. So I got to coordinate all the publicity. I got pretty good at writing emails. And I TA'd a couple positions and a couple classes. So I got to tune up my software analysis and using different softwares for civil engineering. And I also got an internship in land development, which I find pretty interesting. I'm actually coming to you guys from my internship right now. And I also am interested, or my senior year, next year, I'm taking a land development senior design course. So a lot of the times out at schools, they will offer a senior design. So you actually can apply your degree before you enter the workforce. So I will be taking my senior design in the fall. And I'm also a captain of our steel bridge design team. So I joined it my sophomore year, and I actually have the opportunity to lead it my senior year, which is pretty awesome. Lonnie, can you share the next slide? So last summer, I got to go to Europe, and I studied abroad in Europe to look at bridges. So over here on the left, you can see a steel truss. There's a lot of triangles on that. It's pretty cool. And there are just so many different bridge designs that people have used in the past. A lot of these are concrete focused, but there's also a suspension one down in the bottom left, which I actually got to walk across. And I went to Italy, Austria, and Switzerland for the study abroad to look at the different bridges in all of these locations, which I found pretty cool. It was about a year ago today. I was on this trip, and I keep on getting all my notifications and pictures to look at my bridges. So I thought that I would share some of the pictures I got.
Hi everyone, my name's Lonnie. I am actually a senior. I have one more semester, but I did just graduate, so I have my diploma right here. That was a couple days ago, so that's pretty exciting. I am a computer science major at Notre Dame, and some of my interests are web development, so creating websites and applications and stuff. Tech consulting, which if you don't know what consulting is, I didn't know what it was in high school either, and now I'm actually going into that as my job. But it's essentially companies ask you how can they optimize their how they run their business currently, and then you go in and you try to help them. So I'm on tech consulting. So I'm going on the technology side, kind of using my computer science major. And then the cloud, which is something you might have heard of. It's not the clouds in the sky, it's the where all of your documents go, all of your information and your data and your photos you probably get. There's not enough space in the cloud, that kind of thing. So that's also a really big interest of mine. And so for my journey in high school, I went to the local high school near me for all my years. And every single year I participated in PLTW. Some of your schools might have that. It's an engineering program. And I really, really enjoyed it. So I went in college knowing I wanted to be engineering major. I went in with chemical engineering because I thought I wanted to go down that route. But what was really interesting was that freshman year, when I arrived at Notre Dame, I ended up switching my major to computer science. And not that there was anything bad about chemical engineering. I know many chemical engineers and they enjoy it a ton. It's a very different job paths that you go down. But we had an intro course and you got to try out all types of engineering. And I had never taken computer science classes at all in my high school. And I ended up just loving it. So if there's a takeaway from that, just try it all out. You never know what will stick. And I definitely changed course. And then in sophomore year, I joined some clubs, the Society of Women Engineers and Computer Science for Good. And with that group, I kind of got to help teach senior citizens how to use their email and Facebook and stuff like that. So that was a really cool one, good experience. It was some of the projects in that group are a little bit more computer science focused, but mine was just a little bit broader. So you can really do anything. Junior year, I took up an internship in tech consulting with a company that I'm going to continue to work with after I finish up my last semester at Notre Dame. So that's really exciting. And that's kind of how I got down that path of finding those interests of mine. And then my senior year, I just said I graduated with my bachelor's and will continue with Protivity, my company. And I don't have any photos because it's a lot of coding my past 4 years, if I'm going to be honest. But some really cool projects that we did that I wanted to share were we made our own crossword. We made our own Wordle. So if any of you are familiar with that, probably played it at least once or twice. I continue to play it every day, if I'm being honest. And so we got to make one of those. And then I've also created a few websites. So even this semester, I made one for retailers trying to resell their unused clothing. And so it's really cool how we get to have our own projects that we get to decide. It's not necessarily all decided for you, and that makes the whole education experience so much more exciting.
Well, I want to say what amazing introductions from these two young, amazing, impressive ladies with all of their accolades and what all of their experience in just college, when in their college engineering experience. So it is time for our wrap up, and I see a lot of activity. If schools would like to raise their hands in Zoom, we can spotlight you and show you guys, show off your bridges. If you guys are not ready, teachers, you can ask our amazing mentors some questions in the chat. But just to get us started, let's ask Morgan, just because you had those amazing bridge experience, what's your favorite bridge? And I'm going to ask that question to Lonnie next. But Morgan, what's your favorite bridge?
So this is a pretty not well known in the United States one. It is called the Millau Viaduct. It is a cable stayed bridge out in France. It sits above the clouds and it's pretty cool. I think it's really pretty. In the bridge course, we had to write papers on a couple different bridges, on bridge failures, on like pretty bridges and like your favorite bridge. So I wrote mine on that one. And I do have a favorite bridge structural engineer too, and his name is Christian Men. He did a lot of work at ETH, so that is one of the technical schools out in Switzerland. But he actually designed a lot of the bridges that were on my slide. But there are so many pretty bridges. I really like Cable Stayed, which like my family always sends me pictures of bridges whenever they see cool ones.
Love
But that's
that.
a good question.
Lonnie, what about you? Favorite bridge?
I would have to say I agree with the whole study abroad experience. I also got to go away in Italy specifically, especially Venice, because there are bridges everywhere. Simply because there are so many like canals and everything that they need a lot of bridges just to get around. And they're all mainly walking bridges and they are so beautiful. Like in my hometown, I live in the suburbs of Chicago. We have some, but they're very standard, not as historical or just I think it's cool how bridges can also be sort of a piece of artwork. Like they can look elegant or just in Venice and Italy in general, they just looked so much different from what I was used to seeing. So I thought that was pretty cool.
One of the bridges on my slide, it was like a bright red one. That one has been redesigned and structurally engineered multiple times to look the same as its original one. Like throughout different wars, it got destroyed, and then each time they built it looking the same, which I find really nice. And it is like a huge historical thing.
Fantastic. All right, Milton, your time. What's your
Um,
favorite bridge? But I have to say, I think I'm going to see some favorite bridges and some amazing bridges today from these classrooms, right?
that is right. We can't wait to see some of these bridges. Man, we're excited. I see you all are working really, really hard. What's up, Anthony Akers and Archimedes and All Hallows? Man, it's great to engage with you all. Morgan and Lonnie, you all are killing it, man. I don't even know why I showed up. Um, one of my favorite bridges. That's a good question. The Sacramento Tower Bridge. That is a beautiful, beautiful bridge. On both sides of the bridge, it almost looks like one of those towers in a castle that castles have that are close to them. And it has really, really nice tension rods. It's a beautiful bridge. That's one of my favorite. Also, I am from Indiana, Northwest Indiana, which is not too far from the Chicago area. So I kind of like the plain Chicago bridges, but only because I needed those bridges if I wanted to go to places like Six Flags Great America. If you want to travel through Chicago and go, yeah. So yeah, I like those bridges. All right. Jen Scott said, what would your dream job be now that you have an engineering degree? What would be my dream job? Oh, that's not for me. Let me I'm still growing up too, Monica. I still want to figure out what I want to do when I grow up as well. But let me hand that off to a college student to answer.
I guess I can go first. I think when I first went into computer science, one of the things that really interested me was cybersecurity. And so I think my dream job would be something associated with that. And I kind of get to do it on a small scale with what my job is going to be now. Just kind of keeping data private, especially like medical stuff. You need to make sure you have cybersecurity on that. Um, but just continuing down that path, I think it's so cool. You can work for the government, you can work for private companies, and it all just make sure everything stays as it should be.
I think that mine would probably be being a land development or a water resources engineer. So that's just kind of designing where wastewater, different utilities, where stormwater goes. I think that that is really interesting, and there's so many things that you can do with that. I might be a little bit biased because I am working in that right now, but I also would love to be like an engineering teacher. That would probably be my dream job as well. Just both of those.
Love it. Love it. All right. Think I'm gonna put James on the spot at All Hallows. Are you guys ready to share? I saw you pop in that camera for a second. You want to give me a thumbs up if you're ready? All right. I'm gonna spotlight you. All right. Let's see what All Hallows has. You have to unmute though, James. There we go.
So introduce yourself, explain your bridge, and share how much it can carry. You first. You stand up first.
So that's my bridge, right? My name is Ryan Laura. Took me 5 minutes.
Okay.
So it could hold up like 15 pounds.
15 kg.
15 kg.
Kilograms, yeah.
Kilograms, yeah.
Nice.
Speed bridge building.
Yeah, that's really fast.
right, yeah, stand more here so we can see it.
Yeah.
There we go. Perfect. Yes. All right.
All
Next.
right.
Hey, James, are we gonna get a test of any of the bridges? Do we get a demonstration?
Demonstration. All right. We could do
Maybe,
that.
maybe
Yeah.
set them up on a couple books or 2 tables next to each other. Yeah, there we go.
Yeah, we're getting another table here.
Nice, man. That's real engineering in real time. And then if somebody could grab that little platelet, that would be awesome. And the hook we gave you as a way to support it, that would be great. All right. Do we want to come back to All Hallows, Monica, once they're all set up? Is there another group that's ready to go? Any other
I don't have
team?
any hands raised. I saw a camera come on at Abraham Lincoln. Are you ready to share?
Dang,
Give me a thumbs up if you are ready to share.
Archimedes looks ready to go.
We're ready with more.
Oh, let's do it.
Oh,
Let's do it.
all right.
James coming through.
Ooh.
Ooh, nice. You got to spread it a little wider though. We got to get 10 inches, at least 10, right? Man, if somebody kick him in the shoulder, don't kick my guy right there.
I think it's fine though.
So you want to introduce yourself, explain your.
So yeah, it's 14-ish, 15-ish kg, and yeah, just put a lot of different sticks together, binding them with glue, and then yeah, that's pretty much over.
You have some both laterally and horizontally.
Yeah.
So
Okay.
some cross designs here. Yeah. Someone else want to come up? Yeah, you.
Very cool. Great job.
I want to show up that.
Can you put the weight for me?
Yeah.
Oh, wait, you have to tell me about it though. Speak about it. So, my name is Daniel.
Oh, yeah, they can't see you.
I'm still too tall. Okay. Okay, so my name is Daniel Pimentel, and the design of the reason why we made it like this is because we wanted something that's pretty long, but we understand that when you spread it out, you lose durability, and we wanted to make sure that we held durability. So we took all our sticks and we actually mashed them all in here. And then we would put 2 layers on top of each other, so it could go out for a really far range, but it could still be durable.
It was like 16 kilograms.
Yeah, it could hold almost the most amount of weight out of everyone in here.
That was
Get that claim up now.
Yes.
that was an excellent answer because the longer the bridge, the stronger you need it to be. So the fact that they said it's longer and they added height, they added material between the top and bottom, man, that's solid engineering. And maybe you were actually listening to the intro video, so that's great.
Yeah, the
That was a
deflection
lot
on
right
that.
there.
Yeah, the deflection
are
on
they
that looks
testing
pretty
it?
good too.
Yeah, oh, great point. Yeah. Great
Okay.
point.
All right, next group.
Cybersecurity is amazing. I love cybersecurity.
I want to trust that. Yeah, good trust. We have a truss design to show off next.
All right.
Ooh.
Ooh, look at that one. Wow.
Ooh, that looks great.
That looks great. Can you explain it for us?
So we took inspiration from actual bridges, so we put the trusses on, and we also double enforced our actual walkway for the bridge, make it as sturdy as we can. Yeah, basically.
Yeah, you can see there their walkway.
Oh yeah, that's impressive. Very sturdy.
Looks like it has a really solid base as well. That's always important. Oh, look at that, supporting some good weight.
Yeah, that's a lot of weight.
How
How
much
many
weight?
kilograms
How
is
much
that?
weight is that?
15, 16 kilograms here too.
Nice.
Wow.
Nice.
That's like 35 pounds. That's really nice.
Everyone's pretty consistent.
Yeah.
Everyone's is hitting that 15, 16 kilograms. It's really impressive.
That's the most we have.
That's the biggest one so far, yeah. Yeah. There you
I
go.
like that they took inspiration from a real bridge and used the truss design as well as reinforcing the bridge deck as well. That's what structural engineers do daily.
Isn't that cool? Like, I think some of the greatest innovation that we can have is from nature. I mean, the body and the Earth and the universe are some of the most outstanding systems that have been
We have one
developed.
more coming.
Nice.
Okay.
Killing it, James.
I see a lot of future civil or structural engineers
Yeah, yeah.
in this Zoom call.
Okay.
Hi, so we have no clue what we were doing at all, right? So we just went with whatever we thought was right. So we added triangles to the bottom, and we added support to the top as well. And our first trial we got around 6,000 grams,
6 kilograms.
Nice, nice.
and so I guess we're gonna start off with 5. Hopefully,
You gotta do it.
with that.
Need the hook.
Got it? It's like. That's 5.
There we go.
Kilograms.
Okay.
5. We're gonna add another 2.
Okay.
Wow.
And so it's strong. We're gonna add another 2.
So the reinforcements are working.
We got 9 now. We're gonna add another 2. Hopefully it doesn't fall.
Well, we can end now,
That's 11.
because I'm not gonna hear from you or a parent that nobody fed you today. So you need to make sure at some point.
I like the
Wow.
live testing. This is very, very cool.
Very nice. Before we leave All Hallows, oh, they're still going. Sorry.
Yeah, it's bending,
Sorry.
but it's not breaking.
Yeah,
That's
all the
really,
weights.
really
That's
cool.
all the weights we have. Yeah, that's up
Oh
to
my
Wow.
God, they ran out of weight.
that's up to 15 again.
James, before we leave All Hallows, can you just introduce yourself and talk about your role at ET?
Yes, I'm pinned behind a TV. Hello, everybody. My name is James Venditto. I am a PhD, electrical engineering PhD student at Columbia University. I've been with ET since 2019, so that would be 5 years. I started off as a summer intern working on the embedded systems lab. And then I've worked on at summer internships a couple other years, and now I'm an engineering presenter. I also present the embedded systems lab. If you've done that before, you've seen my face and heard my spiel. I'm also a proud graduate of the University of Notre Dame. Go Irish! Also bachelor's in electrical engineering. So yeah, this is my first, not my first time at an in-person lab, but my first time in person since COVID. So this has been very exciting over here at All Hallows.
So glad to have you. We call James the ET guru here.
Right.
Thank you so much, James. And we have another school that is ready to share with us. So I'm going to go to Lane Tech High School. I'm going to spotlight you. You guys can unmute now.
Look at
Can you guys
this.
unmute so we can hear? Let's see.
Oh, they didn't hear you
There you go.
All right. Hi, Sophia.
This is our bridge.
Wait, is it unmuted?
Later.
Yeah, we
First
can hear
later.
you.
There
You're
we go.
good.
Oh,
Okay,
okay,
perfect.
This is our bridge. Yeah. We can just attach the weights now.
So wait,
Ooh, nice looking bridge.
Thank
Nice,
you.
it's compact.
Time out.
Test
The
failure.
zip tie broke.
Zip tie broke.
Okay, hold on. I don't think they put the zip tie on the whole way through. It's a little catch.
All good.
It's a strong looking bridge before I
Right.
saw the failure.
Wow.
How do we Oh, no, they hooked from the bottom. So
Do you know
hook them
how
this
much
way.
weight that is?
On bottom to each other.
What was that?
How much weight is that?
Oh.
About 15 kilos.
About
Yeah.
50.
Probably about 1,000
It looks-
kilos.
It looks very strong. I see that the deck isn't deflecting too, which is really impressive.
Yeah.
I think we don't have much more for our weight, unfortunately.
Yeah. Good.
They ran out of weight. These bridges are so strong that they don't have enough weights to test them. This is awesome. Great job.
Great work, guys.
Yeah.
This looks like it
Um,
could keep holding it if you just keep attaching weights. Like it doesn't look like
Yeah.
it's anywhere close to fall.
Okay.
Hey,
Okay, well,
let's
Actual
go
engineers
Indiana
out at
Hoosiers, man.
Lane
Let's
Tech.
represent Indiana. I got a shout out to the Hoosiers for sure. And it's not easy to develop a bridge like that when you try to connect the valves with just glue. That's really hard. And the fact that that stayed intact is really good. That's excellent. Nice. Very nice.
We have another one from that group. Sorry, I thought they were done. Hold on. I see another bridge coming up for testing. Oh, let's see.
We're back.
We're
We're
back.
just gonna show you all of our bridge designs,
All
even
right.
if we don't have the weights.
Okay, sounds good.
I love how different this one looks from the first one, but it still looks like really sturdy.
Yeah. Still has the trusses going, right? Very nice. You can tell it's great teamwork. They have good teamwork with these teammates.
Yeah, and engineering's all about teamwork, and it's about talking with others and coordinating
That's right.
with your team. So
So what we'll do is we'll hook all of them up right away the first
This one has
thing.
a faulty bottom thing.
I like that they have these standard masses in their classroom too. It makes it easier to measure. So they really can get a good feel for how to compare how strong the bridges are. It's really cool.
They just need more of them, apparently.
Right, Monica? It's a good thing.
Why did none of these bottom things? I don't care, just hold it.
I can see the peace sign in the back. Peace to you as well. I don't know if that's a peace sign or bunny ears. Either way, hilarious.
That's well, I think that's all we
So I
can
guess
do.
that's what we have. We don't have too many, probably 5 kilos we have right here.
Great. Hey, could you ask the students what inspired them to develop this design?
Oh,
What's the
they asked you what
inspiration?
kind of design?
Triangles, really. We thought we were well aware that triangles are the sturdiest shape, so we were going for as many triangles as possible.
Excellent. Excellent. Very nice.
future structural engineers out at Lane Tech.
Right.
Okay, yeah, here, show you something. Okay, we have a few more.
Ooh.
Okay, wait, our zip ties.
Okay. Oh, we don't have zip ties.
Ready.
Okay, we'll show you the next one. Bye. Okay, then throw your bias.
Leo, you better not put the yearbook on.
Okay, you guys, with
Okay.
your zip
You
tie, you
use
have
the
to
tape.
close the
That's
zip tie.
different.
Okay.
I'm gonna relay what Jen mentioned in the chat. I like how all the designs are very different from each other. I really
Yeah.
enjoy that because we get to see how triangles act in different ways. Because I feel like all the designs have used triangles so far.
I love that as well. This one is really different. Wow. Wow. Very nice.
Oh,
One underneath it, or yeah, he's gonna come underneath it.
Oh, way to go, girls. That's sweet of them.
Oh. Oh, we have.
Oh, man. Come on, you got this. Nancy, you put it on- you can put it on the- How do I put it on the bottom here? Oh.
While they're talking through this, question for the interns, mentors, what's one of the toughest design projects you all have worked on? Engineering projects.
Ooh, I would have to say mine's in high school,
These
honestly.
should all be.
It was a capstone to my engineering class, and it was kind of just completely open, and we got to 3D model.
Ooh, nice.
Extremely cool. We didn't get to 3D print it because of COVID. So that kind of got in the way, as it did with a lot of things. But that was pretty cool, but really difficult to learn.
Cool. Cool.
I think that mine is my steel bridge design team. So since each year we get a new set of rules, we aren't allowed to use the same bridge over and over and over again to make it like the best bridge ever. We have to change it and change things around each year, which is pretty unique. I'm actually going out to nationals next weekend
Wow.
for that competition, which is pretty exciting.
So you are a bridge expert. I guess we're transitioning over to Laurel High School and
Yeah.
then Abraham. Let's do
I
it.
know that this
Okay.
team was just testing, but we have other groups that want to share.
Sure, sure, of course,
Fantastic
of course.
job. I love how everybody's bridge
Okay.
needed more weight. There just wasn't enough weights in there. Laurel High School, you are up. Thank you for waiting. Hey, oh, I think we recognize somebody at Laurel High School. Hey,
Hey.
Joanna.
Hi.
Let me introduce you to the amazing Miss Blackwell. Come on.
Hello.
There she is. And we have some really innovative designs that I think if there had been more material, it would have been awesome. Check out this design. Go right ahead. Show what you got.
So this is Darcy showing her unique design. Get a little closer. So
Hi, Darcy.
So moving closer to the camera so you can see the. Come on. So we use our zip ties in a different way. Create a little
Ooh.
suspension bridge. Pretty cool.
Very nice.
That's very cool.
And we are ready to test. Come on.
Excellent.
Yep, sit it here. You can introduce yourselves. Come on. Here. All right, your S is your S hook on there? Deontay, give me your S hook. Is it hooked on there? Where's your S hook? Give me your S hook, the silver one. And then grab the bag. Marcia, grab the bag under the chair.
That bridge looks like a lot of effort was put into it. That looks amazing. A lot of hard work.
Hook the bag. And you are
See
That
some
bridge
reinforced
is definitely
joints
got
at
some
on that
love, for
bridge.
sure.
all right, so we are counting and measuring with water bottles. You don't want to drop it. You want to gently place. So we have 2. Fernando, can you start passing water bottles? That's all 3? Cool. Come on.
It's a very, very sturdy bridge, guys. Good work.
Yes, it is.
I don't see an inch of deflection, not even a centimeter.
Wow.
It's looking good.
I think we might have to get better weights next year. 5, 6, 7, 8. Yeah, get a photo. More water.
Wow. Very nice.
It is still not budging.
Yeah. Okay. Very nice. I think we're just gonna let it go from there.
Shout out to Laurel High School.
Fantastic job, Laurel. Thank you, Joanna, for being on site at Laurel High School. And now we had, oh, they just hopped off. They were ready to go. Where's Abraham Lincoln High School? They just turned off their camera. We were ready to go.
Hey, can we're good to go.
I see you. All right. Here we
Okay.
go. Oh,
Can
look
you
at
guys
this
hear us
bridge.
all right? Can you guys hear us okay?
We can hear
Yeah.
you, yes.
Yeah. So they already set it up. They weren't sure if this is okay or not, but they kind of taped it here. But this is a really heavy bag. We don't know what the weight is, but it's off the floor. So it's just kind of off the floor.
That's a
and it's still
full
holding.
backpack.
Yeah, it's a pretty full backpack and it's off the floor.
All right, Milton, I want you to weigh in on the tape.
Oh, wow. Yeah, tape is okay. Glue
Tape's
can
okay.
sometimes be a little better. Tape, what's nice about the tape is it spans a much larger area. It gives you the ability to have these connections with a much larger area. It's an interesting design too because it comes underneath the 2 chairs. That's really different. We didn't give any restrictions on that, so it's do
Fair
your
game.
thing, right? Become innovative.
Yeah, sorry.
Nope, that's good. You got to think outside of the box. That's important in engineering as well, right? Everything can't be the same. That was really, really good.
So I see some movement at Archimedes, but I'm not sure if they're ready to share with us. Is Archimedes ready? There I see my friend. There's Jerry. Can we unmute Archimedes? You gotta unmute for us.
Hey guys.
Oh, there's
Hello,
our
everyone. Jerry Dawes
Hey.
here, Archimedes High School. I want to introduce our teacher, Miss Nowak.
Hi, how are you guys?
Hey, how you doing?
Awesome.
Yeah,
So, we are ready to test.
let's do it. Let's
All
go.
right.
All right, on the word so they can see the actual. Are you guys able to see it?
Yes.
yes.
All right, guys. So let's start. We're starting with 7 parts. All right, let's put it on. The next one, I'll put it on.
This is a great view too. We can really see it all.
Yeah, look at that huge bucket. Wow. That may be some serious weight. Nice.
All right.
Give me the break.
No.
Give me the break.
Archimedes, Bronx, New York.
Oh, he's adding a brick.
Adding a brick.
Oh man, the tension. No pun intended.
See.
The tension. Look at how
Placed it ever
delicately.
so gently. Ever so gently that brick was placed.
Delicately. Oh.
It's a
Man, don't
very
worry. You
strong
got
bridge.
this. Hey, you got this. You got this, man. You got this.
Brick
You
number
got it.
2 is going down.
You gotta have confidence in that beautiful lady. You got this.
That's the experience.
Yeah, put it on the side. Yeah, that's right. Nice. If it breaks, just blame Jerry. He's there with you. That's nice.
Look at that.
Let's go. That's right. I love the
So
excitement.
that was 18 pounds, right?
You all did a great job.
Can we get the next one?
Well-deserved celebration.
Yes.
So Archimedes is going to test one more bridge.
All right.
Check out the sturdy base design.
There is no budge.
Wow,
That's really
sick.
impressive.
I'm trying to figure out, Morgan, like what's going on at the top of this design.
All right, Archimedes would like to test one more.
Okay, all right. They have a great setup. Archimedes has a great setup. Hey, Monica, is this the last school?
This is the last school.
Okay,
I don't have
last
anybody
school.
else. So yeah.
As Monica would say, you gotta bring it. You're the last one. You gotta bring it. Another nice design. That's nice. Jerry, you're doing a great job out there, man.
Great job by the students at Archimedes.
Yeah, you're doing a great job as well.
No, it's not.
We'll see.
All right, let's.
18 ounces. 18 pounds, ounces.
While they set up the bridge tester, does somebody want to come up and talk about the design?
Please.
Somebody come up and talk about this bridge design while they set up the tester.
Microphone.
Don't be shy. Come on up.
Come close to the camera. You're gonna ask, give your name and then talk about the design.
We made 2 layers of the thin wooden dowels, and then we made a platform
And then we added stuff to make it look slightly better. Now we're gonna test it. So the Ghost Bridge.
Let's go. I love it. They thought about the base first, and then they thought about the aesthetics.
As it should be, right?
Right, you want to
No need in having a bridge that fails, but looks good. That's good.
I told you my favorite bridges are the ones that are pretty. So
All right, here's the test.
All right, let's see it. What do we think? This bridge is going to take the bucket and both bricks? What are you thinking?
I don't know if it can handle a brick.
You don't know if it can handle a brick?
bucket.
Let's see.
Oh,
There we go.
Right,
There we go.
right.
Very solid. Sheesh, I was wrong, Monica.
All right, here comes the first brick. It's holding.
That is nice.
It's holding.
It is. This class, they really should have a competition and get some more weight and see which one's the best, because they are killing it today.
yeah, everyone at Archimedes did an amazing job.
Yes, they did.
It was able to hold both those bricks. Great job.
Yeah, look
Oh,
at
I
that
love
strong
it.
bridge.
Oh, man, I
Future
wish I had a
structural
spring.
engineers.
Yes.
Fantastic job. Thank you so much, Jerry and Archimedes. Fantastic job, everybody. Bye. All right, Milton. I think those are all the bridges we're going to see today. We're back to you and Lonnie and Morgan.
Excellent. Well, I want just to give some parting kudos to you all here. I wanted to just show off some of these awesome bridges before we transition to a very exciting speaker that we have here today, Nicola. Man, you all are going to be blown away. I read some of your background, man. Very impressive, and you just have a great personality, very engaging. So first, I want to just thank Bryce and Morgan and Lonnie and Monica, the hostess with the mostest, and Carla for working the back room, for doing just an amazing job. And, you know, our on-the-spot engineers, Joanna and James and Jerry, they are killing it. Again, if you want Engineering Tomorrow to come to your school, get in touch with Constance and Monica, and they may be able to make that happen for you. So we are going to have a really nice guest speaker for our intro today. You're going to be very impressed, but we're also extremely impressed with your bridges today. Look at that. I want to highlight, this is the paper design. This is the prototyping in this phase. Hey, I'm gonna play with the paper designs first, kind of figure it out. That's great. Also, I love this. Working on the sketch first. I mean, you can't beat that, right, Monica? I mean, if you have a good sketch, you got a good design, then your build is going to go so much better. I also love seeing the students who are just kind of working through the process, putting the parts together before they made their final bridges, right? And man, look at this, look at those trusses, look at this excellent base with those dowel pins, the teamwork, Monica making the dream work. You all were just killing it today. A little aesthetic appeal. You mixed in a little pink, a little blue. That's nice. Extra tape there. And then the testing. Man, oh man, the testing. This school, what's the name of the school again, Monica?
This was Archimedes.
Archimedes.
This is where Jerry is.
The testing, Jerry Dawes. You all absolutely wrapped up our day wonderfully. I mean, to have a whole, I don't know what this is, a quart bucket plus 2 bricks, that shows you all are engineers, engineering tomorrow, and maybe even the structural engineers of the future. And speaking of a structural engineer of today, I want to highlight Nicola Torini. I pray to God I pronounced that right. He's a structural engineer and a project senior manager, right? Also, he's a project manager professional. That means that he had to go through additional testing and certification in order to be a project manager. It's similar to being a professional engineer. That means he's certified as a project manager. He has his BS from the University of Modena. And also before coming to Bridges to Prosperity, he was a project engineer at Faycor. And now he is the senior manager at Bridges to Prosperity, which is a game changer. We talked about this in our intro video. I mean, they are making it happen for countries and regions that just don't have the resources to have access to clean water and all that good jazz. I don't want to ruin it. I don't want to give too much away. So without further ado, can we give a big round of applause for Nicola? He's going to kill it. You're going to be so surprised. Nicola, I'm going to stop sharing and let you take over.
Thank you so much, Milton. And you pronunciated it perfectly. So good job.
That made my day.
And thank you, everybody. It's so exciting to see so many students and so many people like excited about Bridges. You can see like the energy that this kind of structures like bring into everybody's life. So what I'm gonna talk to you about today is a bit of my story as an engineer, but then like how it little by little landed into Bridges to Prosperity. So it's a mashup of the two, personal and professional, which I hope you will like, and you will get a little bit of inspiration in your potential future as engineer. I'm gonna start sharing, and you can tell me, Milton, if you see my screen, and then I will go. Okay, fantastic.
Yep, we can see it. If you can place it in full screen view, that would be awesome.
Yeah, I'm gonna go full screen. If anything happens and you don't hear me or whatever, just like ping me, and I will try to get out of full screen. Anyway, so what we do at Bridges to Prosperity and what I am doing right now, or I'm helping to do, is to build bridges to better lives, which is at the end of the day, the scope of every single bridge that exists in the world. It's to better the lives of the people that are served by this bridge. But as I was saying, I'm gonna start about my my little story, and that starts in Italia, where, you know, pasta, pizza, that. But that's where I grew up and I was raised. In particular, I was raised in a little town called Modena, which you might know or not. And in my childhood, I had like some inspirations. The main ones were to be a paleontologist because of the influence of Jurassic Park, and to be an archaeologist because of the influence of Indiana Jones. I remember like these two main ones pushing me in those two directions. So there was not really a tie to engineering apart from the bridge in the Indiana Jones, but that's just like random. But there was a lot of curiosity and a lot of seeking adventure, you know, and that's very important because that's part of what engineering is. Although I kind of lost it in the way throughout my teenage years, and I was like a little rebel and so on. So it really like I stopped wanting to be a paleontologist. I stopped wanting to be an archaeologist. But then suddenly at the end of high school, I had to choose what to do with my life, and just because my dad is a civil engineer, and that same year they opened the University of Civil Engineering in Modena, 7 minutes walk from my house. Well, I had the good chance to take, and I decided to try civil engineering. And little by little, I rediscovered my curiosity. Really studying the bachelor in civil engineering opens up your mind and brings you to study a lot, yes, but to be curious, to know more about like a lot of different things. You start from math and physics, and then chemistry, and then so many different sciences and technologies go together behind this. And after that, I was so taken that I decided to do a master's degree in civil engineering as well in Modena. So a total of 5 years of study. And at the end of that master's, I got the opportunity to get a European scholarship called Erasmus, which brought me to Madrid. And that's where I rediscovered also the adventure part that I lost in my childhood. And it's been a great 6 months in Madrid where I have been, my scholarship was paying me for working in a company, a structural engineering designing company. And that's where I decided to stay because of the impact in my life of starting living alone in a different country, in a different culture, learning a different language, and all of that brought the adventure together with the engineering development of my career. So I decided to continue in that same company, which is Specor. Milton, you said it before, and I continued working as a design engineer there for about 3 years, focusing a lot on bridge design because of the nature of that company. So I touched base on footbridges, but also like cable stayed bridges or suspension bridges. There was a bit of everything, and it was never the entire project, because the entire bridge project has so many details that needs like a huge group of designers to work on, each one on one detail. So I worked on small details of many, and sometimes I even worked in conceptual designs of some bridges. So I really seen a bit of it all. Starting from doing some initial calculations, then doing 3D modeling and like putting the loads on the model and checking if it stays, because you can recreate what you just did in a software, for example, and then doing the report of all the calculations and submitting it to the client. That's all behind bridges. But then after 3 years there, I thought that I was missing something, and that something was a purpose. And I started looking for it, and I found it with Bridges to Prosperity, which is an international NGO that in fact builds bridges to better lives in rural communities around the world. So I decided to join them as a volunteer. And because of my Spanish gained in Madrid, they have sent me in Nicaragua first, where it's a very poor country in Central America. And there I have spent around 9 months. And in those 9 months, I've actually had a lot of hands-on experience, like building bridges with my own hands for the first time in my life. I was building something like with my own hands, like we were pulling cables, we were like bending bars and like casting concrete all by hands in these remote communities in Nicaragua. And I was doing that with corporate partners, which were volunteers coming from companies that were sponsoring our work, and they were sending volunteers to work on these specific projects with us and to help us finishing them together with the local communities. That's what I was doing for 9 months, and I loved it so much that I decided to continue staying in Bridges to Prosperity. And the next chapter has been Rwanda for me, which is actually located in Central East Africa, a totally different part of the world. This is already 2018, and I've been, if you want, placed there in our Rwanda program as an engineering manager, with the goal of increasing the local capacity of our engineering department, because of the big objective of building hundreds of bridges, of the trail bridges that we build. I'm going to tell you a lot about them. Don't worry, I'm going to give you a little more context. So they were planning to build a lot of them, and they needed a stronger team in the engineering. So that was my job there. I did that for about 3 years as in fact engineering manager. So my biggest responsibilities were leading the design of all of the bridges that we were planning, then following up on technical queries. So during construction, because that's also the work of the engineer. You do a design initially that it's ideal, and then you go break ground, and you always find some problems. You find geotechnical problems, hydrological problem, or any other kind of problems, and you need to make some changes or respond to the requests of the construction team in order to change the design accordingly to the needs. So I've been doing that up until like 2021, where I decided again that I needed I needed to try something new, and I needed to grow in a different way in my career. So I decided to join our partnerships department, which basically the main goal of this department is to find entities that sponsor our work, so that give us money in order to do what we do. And in that, I landed as initially a corporate partnerships manager, leading the part of revenues that was coming directly from the engineering and construction industry. So big companies the engineering and construction behind the building bridges in the world were actually sponsoring and are actually sponsoring our work. And so my job since 2021 includes finding new sponsors or growing the current sponsorship of these companies, which are the same companies that were sending volunteers in Nicaragua. And with this, there is a lot of bridge building with the volunteers that come down, and a lot of inauguration of bridges in Rwanda, which is always a great experience. But Rwanda also gave me a family. In Rwanda, I found my wife, Claire, who is from Nebraska. I don't know if there are like some Nebraskan high schools connected. Maybe you can tell me afterwards. And our son, who she already adopted when I met them, who's called Francois. And I found them both, and I fell in love with them both during COVID, as you can see from the sign in the back. And we got married during COVID in Rwanda, and since last year we moved back to Modena. And so it's kind of like closing the long circle that I opened more than 10 years ago with Madrid. I went back to where it all started, and I went back to the corporate partners that I started with, as I was saying. So all of this because of civil engineering, all of this because of the love for bridges. So this is also the power of bridges in my life, together with the one that I'm going to tell you about now, which is Bridges to Prosperity. What we always try to ask to our audience is like to imagine what would your life be if you had to risk it every day, getting out of the house and going to where you want to go, to work, to school, or to the hospital, maybe if you need. Well, that's how people were living in Modena in the 50s. This is the Panaro River, and these students were trying to cross hanging from a cable, similar to the cables that we use in our bridges, in order to reach school on the other side of the river. But that's unfortunately also how a lot of people, in particular in East Africa as well, are living in 2024. They risk their lives to cross dangerous rivers in order to reach what's on the other side. In this case, it could be students reaching their schools. So imagine if you had to risk your life to go to school, to your high school from which you're calling now, in order to get your diploma and grow professionally. So this is how the dangerous rivers that I'm talking about look like when they flood, which is at least 2 or 3 times every year. And I'm gonna just let it go. This is a construction site. So that's a construction site from a bridge that we were building, and that was a timber bridge that we normally build in order to pass materials from one side to the other during the construction. And you could see how a very stable bridge normally in the dry season is completely washed away by the river flooding. And that's why a specialist organization like us, Bridges to Prosperity, is needed in order to build a longer span that I'm going to show you, and to build it away from the water, which is very important. But let's go back on the people, which are the central part, bridges, as I was saying, because 1 out of 7 people in this world struggle to reach the other side of a river, because they want to reach school, markets, jobs, clinics, anything that is on the other side. And we can do something about it. We envision a world where poverty caused by rural isolation no longer exists, and we build bridges to better lives in rural communities. We've done that for a long time, more than 20 years, and we connected more than 2 million people with more than 500 bridges, and we keep building, and we keep supporting governments in building bridges, which is even more important. We are changing the optic of governments around the world around rural infrastructure. But let's go to the core of it. What is a trail bridge that I've been talking about? Well, a trail bridge is a cable bridge. You have these main cables that are connected to the two sides. I'm going to show you there are different standards of trail bridges that we have, but the main fact is that the main part of the structure is wire rope cable, and they are also 1 meter wide. That's a detail that transforms them not only transform them from footbridges to trail bridges. Why that? Because whatever can pass in 1 meter will pass in that meter. So it's never going to be only walking people, but it's going to be bicycles, it's going to be motorcycles, it's going to be animals that need to cross together with their owners. And this kind of structure is also cost effective, durable, and safe. It's easy to build, maintain, and replicate. So those 6 things makes it very appealing for a scalable plan like we have. We want to connect every person in the world that needs to be connected. So we need something that can be replicated in a safe way and be maintained along during its life. It is currently, as I was saying, rarely considered in the agenda of the government, and that's what we are trying to do to change. And also the way in which we build this kind of bridges, leverage locally sourced and repurposed materials. The cables that I was talking about are donated from ports all over the world. So ports have these big cranes to lift their big loads. And when the cables of the cranes reach like a number of uses, it can't be used anymore. So they normally just throw it away. Well, what we do now is we convince them to respool them and to send it to East Africa in order for us to check it thoroughly with a quality assessment, and then use it on our bridges. But mostly, again, it's about the impact on the people. A study on the effects of our bridges found that the communities served by bridges that we build experience an average 30% increase in overall household income compared to control communities that have not been served by our bridges, or a 60% increase in women entering the labor force. Or when we talk about education, a 200 increase in attendance for girls, or 12% increase in student enrollment, just because there is a 365 days per year connection, safe connection to the other side of the river where there could be the school. Or when we focus on healthcare, we're talking about 32% increase in facility visits or decrease in the health center transport cost of 33%. This is just the tip of the iceberg, but it's to tell you a bridge is never just for itself, it's for the users, and the effects of the bridge are incredible. And there is a total change of mindset in the people living in the area around the bridge when the bridge is going to be built. So that's incredible, and that makes me tick every time that I wake up to do my work every day. And all this explains how bridges like this one can repay themselves in 2 years because of the increased economy of their communities. It's very, very mind-blowing to me. As I was saying, we're focusing a lot in East Africa right now. We have 3 main programs: Rwanda, Uganda, and Ethiopia, because East Africa has a lot of needs for this kind of connection. And we have connected a lot of people, more than 600,000 in Rwanda, more than 150,000 in Uganda. And we're running a program that will connect, in the end, 1.3 million people in Ethiopia. And meanwhile, we're opening a 4th program in Zambia, which is exciting times for the organization. So stay tuned. Also, interestingly, we are expanding our scope to stone arch bridges, which you can think of old Roman stone arch bridges that are still with us. Well, there are some topographies where our cable bridges are not really efficient, and so in those topographies, sometimes this type of bridge will be better and is also cost-effective, sustainable, and durable. And all of the rock and the materials that you use to build it are actually going to be able to come from locally. You don't need to import anything to build this kind of bridge. So another exciting development. But again, let's go back to the trail bridges that we are focusing on right now, which are wire rope cable bridges. Why did we choose that type of bridge? Because it is light. It is very light, and it permits you to make it longer, making you able to span the entire river without putting any pier in the middle. You can imagine that if you put piers in the middle of a river, or just supports, then when it floods, like in the video that I showed before, those piers can be damaged. So you want to stay away from it. So that's why we went for cable bridges. We have standard bridges that are very easily designed. So it's about choosing the distance, so the span of the bridge, and then the difference in height between the 2 points. And knowing those factors, we will know how big the abutments will need to be, how big the towers will need to be, and so on. So in this case, it's a suspended cable bridge with 2 big abutments at the side. It works well when there is a kind of gorge or canyon where there is space for the walkway to hang from it. This is how it looks like in the blueprint. This is 132 meters long, so very long. These are a little bit of the main structural elements. You can see the foundations, the towers, the anchor in the back, and then the walkway system in the front. And these are a couple of photos of suspended bridges. And this is the Nyaruzanje Bridge, 132 meters that you were seeing in the blueprint. And it was 30 minutes away from my hometown, from my home in Rwanda when I was living there for 5 years. Then we have suspension bridges. You think about the Golden Gate Bridge, or, this is a very iconic type of bridge. And we use it when the valley profile is flatter. And when it's flatter, then there is no space for the walkway to hang from it. And so we need to raise it with the cables being on top this time. And then they connect to an anchor in the back, as you see, that is below ground. Here there is the blueprint, and you can see the interesting part of this is there is a footing and a pedestal that are made of concrete. A tower that is made by steel, and then in the back there is this anchor that is below ground with it's a beam, it's a concrete beam below ground with two arms that stick out to get the cables. And this is how they look like. This is the Nyakabuya Mogo, 118 meters long on top of the Mogo River. And this is like the same bridge together with its twin, Nyakabuya and Komane, 75 meters long, serving 3 different points of the same valley, connecting all of these people together. It was very amazing to work on those projects. And finally, we also found the need of a hybrid between the two when the difference in height between the two sides is too high for the other standards. You can see here, we just put a suspended abutment on the high side and a suspension tower on the low side in order to cope with this, creating this almost S-shaped walkway that though looks weird, but really works as well as the others. So this is just like to mention like a little invention, you know, that we found along our way. Milton, I'm gonna go continue with the time that I presumed I had. Tell me when I need to rush, and I will start rushing.
Oh, you're doing a great job. I'm loving this presentation, and just give it a couple minutes and I'll jump in and ask you some questions, man. This has been great.
Okay, I'm gonna continue a bit, and then you tell me when I have like kind of like 2 minutes, and then I will push at the end. I wanted to tell you what's behind building a bridge. It's never just building that bridge. It's about understanding the need before. So what we did in Rwanda was sending out assessors to more than 1,500 sites in order to understand where the bridges were needed by the communities, and some of them have been selected depending on the topography and the technicality to host our bridges. And once the needs assessment is done, then we have our engineering team going for a technical survey with topographic instruments like auto levels or total stations. You can look at like what they do, but basically they recreate the profile of the valley in order to then put it in a computer and start drawing on it and designing your bridge. With that, we create the blueprint and the standard designs with all of the standards that we have. And finally, we deploy as well our construction team that goes and build the bridge together with the local labor that is hired throughout the construction of the bridge to build their own bridge and is trained into the inspection and maintenance in order to keep it alive throughout the years. I'm gonna run quickly through this. I wanted just to give you some concepts of like what some words mean. The river flow direction is the one that defines what is upstream, where the flow comes, the downstream, where the flow goes, the left and the right. And then there you are gonna put the bridge center line, which is basically just the center, a line that passes through the bridge. And we generally start with the positioning of the center line, which is where the people currently cross. You can't put a center line of a bridge. You can't build a bridge where people don't cross, because they will keep crossing where they were crossing before. So it's important to see where they were currently crossing, either on a log, either swimming, either jumping on rocks. It really depends. When there is no bridge, people invent ways to cross. Then you need to find good places for the footings and the abutments. You need to check the ground for geotech, you know, to know that the ground is going to be strong enough. Then you need to give enough backstay for the designer, you know, in front of the computer to play around and decide the length of the bridge. And finally, check and keep the difference in height small, because the more difference in height, the more disequilibrium there will be between the loads at the side of the bridge. giving you a lot of information, but I hope that it's simple enough to be understood. The most important thing that you need for a bridge is to understand the past of the river. That's really the highest danger for a bridge, and so we spend a lot of time checking signs of the erosion of the banks into understanding like what happened this year during the floods and like how the erosion can go backward and eat ground in front of the bridge, which we check for meanders, which are the curves of the river. So you see an initial solution that could have been 50 meters. You can see that the curve upstream of the river can actually be eroding up to the center line. And so we would need a longer bridge in order to make it with more longevity. Then we need to avoid upstream confluences because that's just messy. It's an area where there is a lot of energy and the rivers just go right and left all the time. And finally, the most important thing, we need to check the high water line, which is the highest level that the water has reached in the past. And that's normally we ask old people to tell us because we don't have data there. Tell me, Milton.
No, this is so rich. I mean, I hope you all are enjoying this. I mean, it's not just bridges. It's loaded with life lessons, man. It's just it's really good. So can I jump in and ask you some questions? Is that cool?
Yes, please.
Okay, I'm gonna start with questions students provided because they're the most important, right? I'm not as important as them. If you stop sharing your screen, people can kind of see you a little better as well.
Yeah.
So you said something that was so profound. You said, imagine if you had to risk your life to go to school. I mean, I hope you all are thinking about this. Imagine if you had to risk your life to go to school, to go to a hospital, to go to the grocery store, to even just have access to things we're addicted to, like the internet, right, Nicola? I mean, these bridges are really game changers in people's lives. So I got a question for you. How do these local communities respond when Bridges to Prosperity arrives to partner with them? How do they respond?
Yeah, that's a good question, and it's at the base of the sustainability in the way that we work. We firstly always come together with the government. So we always partner with the local government. We never come alone and say, you need a bridge. We come with a local government where the community already asked for a bridge, so they already know their need, and that's very important. You can't go to someone and tell them like what they need. They already like need to, or there needs to be much more behind it. So that's the first point that makes it easier to tackle. And many times there have been injuries and deaths trying to cross the river for that community. So they know the importance of a safe crossing. And the other thing of a bridge is the simplicity of the concept. It's a concept that anyone in the community understands. You don't need education to understand what the bridge is going to be used for. The 2-year-old or the 85 or 90-year-old uneducated community member will understand and will use it from day one in order to reach like their social network, their hospital, or their school. So that's the other magic part. Plus, we hire local labor. So we also give jobs to the community for 3 months, like during the construction. So there is all of that making it, appealing and understandable from their side.
That's a game changer. I didn't even appreciate that when you all come into the community. I mean, something you said that was unbelievable is, one, you train them so they are able to sustain, right? And they pick up these skills that they can take other places, right? I mean, they can design and develop bridges and maintain them once they leave. But also they're getting some income, which a lot of times in these places, they don't have a lot of income. That's just, oh, man, Nicola, that's good. The last point, I hope you all heard this because he said something that was really important. he said if there is no need, like if in engineering, if there's not a need, then why are you designing it? You know, why make a product? But anyway, man, I'll just keep going. That was so good. So another question that came out was students asked about new technology and bridges. And I'll let you address that after I go through this question. But you also talked about bridges that you're working on in Bridges to Prosperity that were stone arc bridges versus these trail cable bridges. That's kind of new technology for Bridges to Tomorrow. So what does it make to like how do you make that shift happen? Like what needs to change in terms of the time to build, the expertise of the team, what are limitations? Like what did you have to change to go with something like that?
Yeah, that's an ongoing process, and it's happening because we are partnering with another organization, which is Annabelle, the Belgian development organization, who built that kind of bridge in Tanzania. They built more than 200 of these bridges, so they have the expertise and the know-how, and they approached us in order to create this coalition into like making a broader scope of work, acting on places where we were not acting before because of the specific technical parts that are needed in order to build our trail bridges. And so it's really complementary as a solution. So that's important. We're not covering the same places that we would have covered with trail bridges. And the expertise and know-how of this organization are going to be transferred to our engineers, which are going to have to study, like it's a long life studying engineering, which also it's part of the curiosity that I was talking about. It's the beauty of it. And so our team is now currently studying both on the design side and on the construction side in order to make these structures sustainable in our way to work.
Wow. I mean, your answers always have like multiple answers within them. I hope you all caught that was really good that you don't have to figure it out all by yourself. I mean, in engineering, teamwork, partnerships, that's that's the way to make it happen. So, Nowak in the chat, Nicola asks, out of the many bridges you've helped build, were there any that proved to be a real challenge for you and your team? Like, what is your greatest project challenge?
Greatest project challenge? It has been generally the biggest problem that we might find is to encounter rocks at a certain point of the excavation. It's hand excavation, like all of what we do is in remote parts of Rwanda or East Africa, so we can't like have big machineries, also for cost wise. And so everything is by hand, so it takes a while to reach like the bottom of the excavation. At a certain point, you just hit rock, and you just did not know because we don't have like crazy geotech checks and stuff. We just like think, and so sometimes and more than sometimes we just need to make a longer bridge than what we expected, and that means that you need to change the contract and get more money from the government and then change the design and so on. So I think those are our biggest challenges generally. Specifically for me, the biggest challenge and the most challenging bridge was the first one that I've built in Nicaragua. I was coming from a nerdy setting behind a computer, designing and making calculations, and I've never built something like that. And so it's been humbling to see all the skills that are needed in a construction site to make it safely and to also make it technically good.
Yeah. It sounds like you have a family. I don't know if this is a new family or what, but also you like go across the world, like building these bridges. How do you balance all of that, like with the family, and then you're just in Rwanda or somewhere, I'm thinking for months, like does your family go with you? Like how do you balance all of that?
Well, the part of like building bridges with my own hands is kind of like more in the past. of like the beginning of my trip with Bridges to Prosperity. I'm now, like, as I was saying, more focused on partnerships. So I'm chasing the people and the companies and the foundations that might be able to support us more than being directly connected to building bridges, which we have a huge team in East Africa that does that much better than I could, luckily. So I actually travel more to create new partnerships than to actually like build bridges directly. But yeah, it's with my family here that now we're all living together in Italy. It's challenging to travel for your work, so you really need to plan in advance to make it clear, and you're gonna miss them, and they're gonna miss you. So it's important to keep the communication up and just wait for your return.
Yeah, I forgot you're like the top dog now. You're the big cheese. So it's a different phase. That's really cool. It also makes me think, just because you said Italy, you have to know that Constance and I would love to bring engineers tomorrow to Italy. So we gotta get with one of those schools.
Oh yeah.
And we don't have to do that through Zoom, right? We can just come on over from the plane. But in all actuality, someone in the chat asked, how can you volunteer and be a part of Bridges to Tomorrow? You have such an awesome program. And I'm thinking there may be opportunities where they don't have to go out to that community, just like you're working remote. Maybe there's remote opportunities for them to be a part of Bridges to Tomorrow, Prosperity. So how do they partner with you?
So historically, we've been growing a lot. So when I started 8 years ago, there were more opportunities for volunteers to start and to be sent like in a remote like place and just like deal with things cowboy style, I call it. But now the reality is that we grew a lot, and so we are like grew a lot our actual team that works for us, and so we are looking more for very good professionals that already have the experience and that want the job with us. And the volunteering part remained part of the corporate program, which I lead, and goes through the companies that sponsor us. So if you work for a company, for one of the companies that sponsor us, that could be in construction, engineering, or architecture, then that company can sponsor a bridge and then send a group of volunteers to work with us and support basically the community work and so on for 2 weeks. That's a specific way that we tackle the volunteering. So, if you're going to be an engineer and you're going to end up in one of those companies, maybe one day you're going to come to East Africa and build a bridge with us.
Very cool. And that may even expand some of the opportunities to get involved. That's so good. Well, this is our time. I really wanted to ask you about Jurassic Park and why you enjoyed it, because that's one of my favorite movies, but I have run out of time. I do want to just give you a really quick shout out. This was an outstanding presentation. Can we clap it up? I called this, Nicola, a purpose-driven life. Your story is so powerful, and the way, like, you turned the challenges that you all had as young people in Italy with not having access to bridges to your purpose in life, I thought was wonderful. Some things I've caught was building bridges to better lives. We're better together. I mean, even outside of bridges make the connection, but in general, in life, we're all better together. This equation I stole from you, solving problems. You took your passion, you took your purpose and some perseverance, and now your bridges to prosperity, which is excellent. I also heard that old can become new, how you all use older materials and older resources to develop these bridges. Man, you all got to remember that you can reuse and repurpose stuff. That's better for the world. I mean, sheesh. And then it's never just building a bridge. The people matter. You got to start. Every problem has to be a solution for people. Else, what problem are you trying to solve? And then last, I threw this in with bridges. Knowing your path is important. That's a life lesson. You gotta You got to figure out your path. You don't want to follow somebody else's path. You all have unique gifts and strengths. Follow your path and you'll do your best. So again, thank you so much, Nicola. That was excellent. And I am going to hand it off to the marvelous Monica to talk about next steps.
Well, thank you so much, Milton. First of all, I have to say thank you to Milton and Nicola for an amazing keynote presentation here, hitting all of those student questions that they submitted in advance. But we have to give a shout out to our teachers and our students, and also our engineers who are live at schools today. We have one more event coming up this year. We have our aerodynamics event. Teachers, wouldn't that be a fantastic way to end the school year, to have an Engineering Tomorrow engineer live at your school on June 5th for Aerodynamics Day? Just saying. But back to housekeeping, we need teachers to complete your exit tickets. Students, please complete your exit tickets. You guys have done a fantastic job today. I see Bridget still in the cameras at Laurel High School. Fantastic job today. Everybody, thank you again, and we hope to see you for the next one.